Our next presenter is coming from the University of Leuven. Liesbet Vranken, you're full professor at university, and Liesbet has a work package lead in the sustainable assessment work package. The floor is yours.
Okay, yeah. So indeed, I was leading the work package that looked at environmental, socio-economic and health impacts. So later on, the colleagues from Nutris will talk about the health impacts. I will look at the environmental, socio-economic opportunities for local food processing. So I'm Liesbet Vranken, but the work that I will be presenting here is done by a team. The bulk of the work has been done by Lorenzo, who's here in the audience. He worked both on looking at those environmental, socio-economic opportunities. And then Erika, who is here, she also contributed to the economic assessment. And then Tim, another colleague, contributed to the environmental impact assessment. Okay, that being said. So, yeah. Okay, so we did, this whole project was about local small-scale food processing. So a key question is then, okay, to what extent are those small-scale processing technologies, are they better from an environmental point of view, and do they provide viable economic opportunities? So let's first look at the environmental impact. So we wanted to know, okay, are they indeed more sustainable from an environmental point of view? So we wanted to assess the environmental performance, and we decided to compare the impact of the food product with some substitute products. Technology or the methods to be used was life cycle analysis. So this is a methodology to assess 60 different environmental impacts. I think you have 16 impact categories throughout the lifespan of a product, so from cradle to grave. So we decided to compare the Fox products with substitute products. So the first question is then, of course, which are substitute products? So with that, we relied on some insights from the consumer survey, and we actually defined different products compared to the Fox products, some that were assumed to be healthier, more environmental friendlier, others that are perceived to be unhealthier, but comparably from an environmental point of view, other set of products that are comparable, received comparably healthy but less environmental friendly, and then a fourth category of products that are perceived unhealthier and also less environmental friendly. So concretely, in case I just here, what substitutes did we look at for comparison? So here we listed them for each food circle. So recall food circle 1, that was the apple juice. We compared it with homemade juice, a homemade smoothie, or a standard non-fresh juice, or a homemade juice, and so on. So for each for each Fox product, we defined a set of substitute products. And then we compared the environmental impact of the Fox product with those alternatives, with those substitute products. Okay, so what's the result then of those findings? Let's zoom in first, circle by circle. So what you see here, I know the font type is small, so you probably cannot read it properly, but the main thing is to look at the height of the bars, right? The bar on the right is always the bar indicating the environmental impact of the Fox product. So in this case, of the apple juice. And what you see here is if you look to 8 substitute products, that Fox apple juice is scoring rather well. So maybe just also on the left panel, this holds for this food circle, but also for the others, we have the environmental impact expressed as a single score. So that combines the 16 impact categories on the left per kilogram, and here per portion, what you normally eat, a portion that a person normally eats. And what you see here, that apple juice is actually performing rather well. It's comparable to some other juices that are in the market, but much better to other than more like tropical juices, for example. So here, product is scoring very well. Moving next to the dried apples. So we have been eating those dried apples, very tasty. But unfortunately, if you look to the environmental impact of it, that product it's not scoring that great, right? Especially if you express it per kilogram, it gets a bit better if you express it per portion, because you do not eat that much of those dried apples. So here it's a bit in line with some of the substitute products, but still it's not the best performer of the class. Maybe worth mentioning here, we also looked at, okay, why is this product not scoring that great from an environmental point of view? And we saw that this has to is related to the energy use. So it's a rather energy intensive technology. So this also gives some insights for future product development. You might, if you want to bring it to the market, think to what extent can we make it more energy efficient? We were talking during the break about it, maybe including some solar panels on the roof or something like that, because that would already improve, lower that environmental impact considerably. So this is some of the things that during the project, it was quite challenging to do this environmental impact analysis. Why? Because the technologies, so for such an environmental impact assessment, you need to have a lot of data, right? From a product that is developed already, but those products, technologies, were still in the process of being developed. So this was a bit challenging. So we worked with the data that we get. We had to make some assumptions here and there, but we do think it gives some valuable insights for the technology developers. Where can we make improvement? Where are there opportunities to seize? So this is about the dried apples. Then if we move to the fruit mix, so this is in food circle 3, you see that Fox fruit mix is scoring rather well in terms of, especially if you look at the impact per kilogram. Per portion, it's doing a bit less good, but still it's a bit in the order of magnitude of many of its substitutes, so doing rather well. Then moving on to the fox soup. So earlier on, Ariette talked about the proteins from peas. Well, one of the things that are also being developed by the Dutch partner is that soup that is made from food waste. So we compared the impact of that soup with some substitute products going from homemade soup over a noodle soup and so on. And we see here that the environmental impact is rather okay, but maybe a bit higher than what you expect up front, because it's made from food waste, from tomato food waste from tomatoes. Well, what we zoomed in then a bit further and we looked, okay, why is that impact then so high? It's really a bit in contrast, it's not what we expected up front. And then we noticed that this was highly due to the recipe that was being used. So I think there was some cream being added, cream made from milk, dairy, high impact. So this also gives some guidelines on the product developers there. If, okay, you want to use the food waste, this is of course a good thing already, but if you then want to further improve its environmental impact, lower the environmental impact, well, you might rethink the recipe and maybe use a bit less of that cream. So in that sense, I think those environmental impact assessment, it shows, okay, those Fox products have a potential, but there's, in many cases, it also, there's room for improvement, and this life cycle analysis highlights in which area improvements can be made. Then moving to the economic impact assessment. So there we wanted, okay, we want, if you have those local processing technologies, local products, one question is, are they more sustainable from an environmental point of view, but it's also economically feasible for an entrepreneur to adopt to those technologies. So this entrepreneur can be a farmer or a group of farmers buying the equipment, or it can be an entrepreneur that buys the equipment and sources the products externally. So how did we go about investigating this? So it has been mentioned earlier today, prototypes are being developed here. the costs of it are typically rather high. And this, if we bring it to the market, probably the real costs will be much lower than the cost of the prototypes that are being developed here. So what we decided to do is to think, okay, let's work backwards, so to say. We're going to look, okay, for this type of product, a juice, what's a competitive market price? What can someone ask to when he sells it on the market? Then we were going to look, okay, what's if we want to run this machine, this mobile unit, what are the different costs that an entrepreneur, an adopter, so to say, would face? What are the variable costs that he would face? How much labor to be used? How much inputs need to be acquired, like energy and water? What's the price for that? So we looked into all those aspects, and then we calculated backward. If this is the price that he gets, these are the variable costs that the adopter is facing. How much can that entrepreneur pay yearly to rent the machine or as to invest in acquiring the machine, to repay his loan, for example, to acquiring the machine? So we calculate the maximum yearly investment cost. And because we believe that this could be very relevant also for the developers to think, okay, if this is something, the maximum yearly development investment cost for an adopter that he, in order to still be break even, you can calculate this is what the price of the machinery can be in order for the adopter to still be willing to buy it and be break even. If that cost would be, or that investment cost would be way too low, maybe it's very unlikely if the developer then says, we can never develop such a unit for this price, you might want to reconsider whether it's worldwide investing in developing the local processing technologies. So what we did here, we looked, okay, what's the maximum yearly investment cost? What price does an entrepreneur, an adopter of the technology, how much can he yearly spend for renting the mobile unit or for investing if he acquires it in ownership for example, repaying his loan for it. And of course, that varies with the price, right? So how to read those tables, those figures, so it's for the 4 food circles, and it indicates at which price, right? From which price, from a certain price, you can, like here, for example, at a price of 140, which is a rather competitive price for a fruit juice, I think. Milena, no? Yeah. Like 140. Then you can learn here that an entrepreneur can, on average, repay or pay a rent of 25,000 to acquire the mobile unit, right? This you can then calculate. If he uses it for 20 years, it would, even if the machinery, the mobile unit would cost up to 500,000, being 25,000 times 20, the lifespan, he would still be able to be break even. So it's an economically feasible option. So we got insights, okay, here, like at the price of 140, for example, it's feasible to make a considerable investment and still be break even. Similar conclusions were held for food circle 3 and food circle 5. If you look at a competitive price for the product, in all cases, and that was for food circle 1, 3, and 4. If you had a competitive price, an entrepreneur could make a considerable investment to acquire the machinery and still be break even. This was a bit more challenging for food circle 2. And you can think, okay, maybe that's the energy thing that plays a role there. Though what this analysis learned, and again, I think this is useful for future development, that was also related to the packaging, which is rather costly. I think the way we looked at it was like the apple chips, which are very nice, but in always small portions. So a lot of packaging, the high packaging product ratio. So for example, by improving that, because the packaging was a rather big cost factor, by improving that, the economic feasibility would improve already. So these are the type of insights we got from that analysis. So moving then to the conclusion, okay. Moving 2 slides conclusion, and then I'm done. Environmental impact, if you look at that, those FOX products are locally, small scale local produced products, they can either outperform alternatives or at least have an environmental scores that do not significantly differ from those of the substituted products. Each food circle has its own challenges, and you can learn from that life cycle analysis. Learn where there are opportunities for improvement. The Fox apple juice, for example, in food circle 1 was doing rather well from an environmental point of view. If you want to improve its environmental impact, one can think of replacing the glass packaging, and maybe also think of more sustainable methods for managing bio-waste that is generated during the process. So this highlights opportunities for improvement. The dried apples, you can think of changing that packaging to product ratio, as the packaging has also a high environmental impact, and also thinking of making the technology more energy efficient. The food circle 3, so yeah, there it became clear that most of the environmental impact stems from the agriculture phase. So if you want to improve the environmental performance of that final product, important to think, okay, where are we sourcing our fruits and vegetables? Where are we getting them? So because this will also play a role in the final product. For the tomato soup, the recipe that we looked at, that learned that, okay, and now some highly processed ingredients are included in the recipe, while replacing them might provide opportunities to improve it. And then from an economic point of view, each technology has the potential to be economically viable, but again, some future developments are advisable or could be needed. If you look at food circle 1, promising output, but it might improve its economic feasibility by improving packaging. Food circle 2, a bit more challenging. One can think of also changing the packaging to product ratio, but it was also rather labor intensive. So also there may be if some more mechanization is possible, might be useful as well. Food circle 3, there we also noticed that, okay, where you source is important from an environmental point of view. From an economic point of view, it's also to have a higher production capacity with a similar labor input would play a role there as well. Food circle 4, also rather promising if you have competitive prices. What made a big difference there, and which is of course rather straightforward, how you acquire those food waste streams. Do you have to pay for it to acquire them, or do you get them at no cost? Maybe the company that generated the waste is happy to be rid of it, or maybe that company might even pay you in order to come and pick up your food waste sources. Of course, that played a big role, but overall also rather promising outcomes. And with that, I conclude the presentation and happy to answer some questions. I hope I more or less stayed within the time.
Yes, thank you very much, Liesbet. Thank you very much, Liesbet.